Alright, let's read the following about functional notation. It says directions. Read the following information about functions. As you're reading, keep these two questions in mind. What is a function, and how are functions expressed? So let's look at the introduction. What is a function? A function is a machine that takes in something called an input and uses it to produce something called an output. So a food processor can be thought of as a function. The name of the function below is f. Consider the images below. When you have a food processor, you have your input or your food goes into the processor, the machine does something to it, and the output comes out. So for example, you can drop in a carrot into your food processor, the machine cuts it up and gives you sliced carrot. So in this case, the carrot is your input, and the sliced carrots are the output. And the notation we use is f with parentheses around the input equal to what the output is. So the function f, that's the name of our processor, acts on the input, which is placed in the parentheses. So my input is inside of the parentheses. The output is shown on the other side of the equal sign. So the output in this case was sliced carrots. Let's consider a machine that uses numbers. What happens to the numbers that are placed into this machine? So taking a look at the bottom, when I input my number, because here are my inputs, they go into the machine and then out comes another number. So when 4 goes in, 16 comes out. When 3 goes in, 9 comes out. When 2 comes in, 4 is out. When 1 is your input, 1 is also the output. And when 0 is your input, 0 is their output. So let's write these using that function notation we used with the carrots. So the name of this function is f. My input is 4, and my output is 16. That's the first relationship between the numbers given there. The next one, my input is 3, and my output is 9. My input is 2, and my output is 4. My input is 1, and my output is 1. And when my input is 0, my output is 0. Notice that when we've dealt with parentheses before in math, generally parentheses would mean multiply. But for functions, these parentheses do not mean multiply. So it's a big distinction between what we're used to doing. What this is telling you is that this is the input for the given function that you're working with. And in this case, it's the name f. Has anybody figured out the pattern here? What are we doing to our numbers in the machine to get out these outputs? So if I input any number, so I'm just going to pick x. So if I input x as any number into this machine, what's going to happen to it? And based on the pattern I'm seeing here, these numbers are being squared. You're taking your input value and you're multiplying it by itself. 4 times 4 is 16. 3 times 3 is 9. 2 times 2 is 4. 1 times 1 is 1. And 0 times 0 is 0. So this is our first introduction to function notation. Again, this does not mean multiply with the parentheses. This is just telling me that this is my input value that I'm plugging into this function. So let's keep looking at it. Functional notation is a way of representing functions algebraically. Function notation makes it easier to recognize the input, or your independent, and output, or dependent variables or values of an equation. The function f parentheses with x in the middle is read as f of x, and it indicates that x is the independent value. This is your input. So let's consider a situation. Consider the equation c equals 8s plus 15, where the independent variable s represents the number of shirts ordered, so s stands for shirts, and the dependent variable c represents the cost of the order. So s is for the number of shirts you purchase, and c is the cost, the total cost. The equation can be written using the functional notation as c of s, c parentheses s, equals 8s plus 15. The cost, c, is a function of s, the number of shirts ordered. So the cost depends on how many shirts you're ordering. C of s. The process of calculating the value of a function for a specific value of the independent variable is called evaluating the function. So for example, the cost of ordering 4 shirts can be calculated by evaluating the function at s equals 4. This is written as c parentheses 4 in the inside and is read c of 4. So what is the cost if I purchase 4 t-shirts? To evaluate, you plug in 4 for s in the rule and then you solve. So notice I'm replacing s with 4 in both the input spot and where s is in the rule. So if I plug in 4, I plug in 4. Again, remember this does not mean multiply. You are not multiplying c times 4. It's saying what is your output when 4 is your input. 8 times 4 is 32. 32 plus 15 is 47. So the cost of 4 t-shirts is $47. You could plug in any value you wanted to. Let's say I wanted to find the cost of 5 t-shirts. So I would plug in 5 for the variable s, where I see it. Again, I do not do anything on the left-hand side. That is just telling me what the input is, but I can solve the right-hand side. I'm plugging it in. I would get $55 would be the total cost. So I can pick any value I want for s, plug it in, and I should get out a different output. So let's practice using functional notation with equations, tables, and graphs. I'm going to go through one example that has all of them together for you, and then you're going to look at the other ones individually, but there will be videos to support if you need extra support with them. So turn the page to example 1. Right now I know this is a lot, but hopefully with the example it'll start making some sense. So let's rewrite the following equation into functional notation. Let's say you work delivering pizzas. You charge a flat fee of $5 plus $1 per pizza. So if you deliver pizza, you're getting $5 and then $1 per every pizza that you deliver. Let's write a function representing the cost, c, of delivering p number of pizzas. So c represents your cost. P is my input variable because that is the independent. The cost depends on the number of pizzas you sell. And in the equation, I can come up with an equation from the information in the question. It says $1 per pizza, so that's 1p plus your $5 fee. So there's my equation. Using this equation, complete the table, graph, and answer the questions that follow. So using this equation, if I purchase 1 pizza, 1 times 1 plus 5, that gives me 6. So that means the cost of delivering those pizzas is $6. If I purchase 2 pizzas, 1 times 2 plus 5 equals 7, so that's $7. 1 times 3 plus 5 is $8. Notice all I'm changing is I'm changing the input, my number of pizzas, into my equation. 1 times 4 plus 5. And by now you've probably seen the pattern and figured it out. So this probably looks familiar from when we were working with solving linear equations and graphing. So functions are very similar to the graphs that we'd worked with before. So if I plot these points, I've got 1, 6, 2, 7, 3, 8, 4, 9, 5, 10, and then 6, 11. So I'll just have to estimate where 11 would be up there. So let's use this information to answer the questions. What does P represent in this problem? So P is the number of pizzas ordered. To be delivered. What does C of P represent? So C parentheses P. Remember, this is not multiplication, this is function notation now. So it's saying, what does the C of P represent? And remember, we used the C of P and it replaced our Y value, which was traditionally our Y value. And in this problem, it represents the cost. So this is the cost of delivery. So what does C parentheses with 4 on the inside mean? This is C of 4. What does it mean? So C of 4, if I look at it, C of 4 is 9. And you can look at it in the graph, or excuse me, in the table. C of 4 equals 9. You can use the equation, or you can use the graph. If I go over to 4 as my input, 9 is my output. In this problem, it means delivering 4 pizzas costs $9. All right, let's look at this question. What does C of P equals 10 represent? So let's look at where C of P equals 10 back at our table. C of P equals 10 when I have 5 pizzas being delivered. So what that represents is the cost of delivering 5 pizzas. So we can use the graph, the equation, or the table, and here's the official equation, to figure out the answers to these questions. The big key again here, C parentheses with P on the inside does not mean multiply. This is just naming your function and what the input variable is. This is your rule where you plug in the numbers and solve. So you're going to practice using tables, graphs, and equations to solve functions today.